So this is a podcast on some of Geert-Jan van Oldberg's paper that he led, his last contribution before he unfortunately passed away at a very young age of 59 last year in 2021. And it's a cautionary note on why we are not so good at doing attributions with models yet. As you know, when extreme events like a heat wave happens, immediately there will be a lot of climate priests going around saying how much worse. Well, first is to say it was made worse by climate change, and then there will be some numbers like Pakistan heat wave was made 30 times worse by climate change or human activities. So human activities and climate change here have to be looked at more carefully as well. So this figure became very famous during the summer of or early summer of 2022, and you can see the extent of the warm temperatures and the duration, frequency, intensity, and the area covered by the heat wave were kind of record breaking. And yet you have to understand what was made worse by climate change and what was the global pattern versus the local pattern. Okay, so this is another infographic from Al Jazeera, which is where I got this as well, which is a modified version of NASA figure. So this is just showing what is the highest temperature ever recorded in your country, and the main point is that the warmest temperatures in Death Valley was in 1913, and the warmest or the strongest heat wave happened during the Dust Bowl in the 1930s, and Europe has had more recent ones and so on. So this means that you have to be careful also as to when the warmest temperatures occurred and how they are changing. So climate tends to load the dice, so frequency of extreme events can increase, but then in the case of attribution, the question is, what does it mean locally? Models may be good at large scale patterns. Somebody's shouting here, so let me stop. So the idea is to figure out what was changed by climate change. What was altered by climate change? Was it the probability of the occurrence? Was it the amplitude of the heat wave? Was it its duration? Was it its spatial coverage, and so on? And the main message from Van Oldberg is that models are right now not good enough, and we'll see that sometimes even the data is not good enough, because when you want to do attribution, you want to see a long enough time series to see what has happened in a particular place like Pakistan, and especially has to be much more specific location within Pakistan, so that over the historical record, how does the current heat wave compare in terms of its probability of occurrence, its intensity, maybe its duration, and maybe its spatial coverage, and so on. So the paper is attributing and projecting heat waves is hard. We can do better. So always a modest guy, great scientist, contributed a lot to extreme events research. Let's read his plain language summary. Heat waves are arguably the most deadly weather phenomena. As the Earth warms due to higher concentrations of greenhouse gases, one would expect heat waves to become worse as well, killing even more people unless they are better protected against the heat. However, it turns out that the world is not so simple, and that many other factors also influence heat waves. Land use changes, irrigation, air pollution, and other changes also drive trends in heat waves. So some things may cool, some things may warm. Aerosols may cause solar dimming. Irrigation is now argued back and forth whether it makes heat waves worse or has no impact, and so on. Some of these cause much larger trends, while some have counteracted the climate change driven trends up to now. In some regions, the causes of high trends have not yet been identified. Current generation climate models often do not simulate all these mechanisms correctly, so will have to be improved before we can more confidently trust their descriptions of past trends and projections of future trends in heat waves. As many of you know, there is a cottage industry of using CMIP6 models or whatever class of IPCC models to say what will happen in the later decades close to 2100 in terms of heat waves, droughts, etc. But often it's not stated clearly that at that time scale, scenario uncertainties often dominate the projections. At shorter time scales in the next decade or two, model uncertainties tend to dominate the projections. So this is also important to keep in mind, because if the projections depend on what the scenario is, what are the chances that those scenarios are going to be realized? If you just look at how things have evolved in the last couple of decades, especially in response to COVID, you know that you can throw out all your scenarios out of the window. So this is showing here trend in the highest maximum temperature of the year TXX as a regression on 4-year smoothed global mean surface temperature, so that you get an idea of how the local warming or cooling is compared to the global mean pattern. And the idea is that models are in general good at larger scale patterns given the greenhouse gas forcing, solar forcing, volcanoes, etc. But as you zoom into more and more local scales, the models are just not good enough. This is the global network data stations with a minimum radial separation of 2 degrees and at least 50 years of data in the 1900 to 2019. And so this is for the previous slide is for 1900 to 2019, and this one, so we are looking at 1900 to 2019, and this one is more recent period 1970 to 2019, and at least 30 years of data. The main point you want to understand is that there is more warming over Europe and more realizations of the highest maximum annual temperatures, whereas there is a conundrum over the US, where in fact there have been drops in the highest annual maximum temperatures, and India has not seen much of a change in that over this period of 1900 to 2019. So models have to be able to capture these, especially local trends like this Southeast Australia, for example, and the models are not good at, they do large scale patterns very well. For example, they may capture European scale warming and relatively more warming here than here, but many may not capture these specific trends of a reduction in, so look at the scales here going from minus 2.5 to plus 2.5. In the more recent period, India is still a mixed bag. There are many negatives here and some positives. So what is happening? Obviously, there is the global forcing from increased greenhouse gases that produces certain trends, certain patterns like the polar amplification that we have talked about elsewhere. But when you zoom into local scales, models begin to have difficulties, not least of which is because of missing representations of local land use, local urbanizations, local agriculture, irrigation, pollution, short-lived pollutants, etc., etc. Okay, so this is something that we have to watch for. Here is another way to look at it. This is looking at a particular place in Netherlands, De Bilt, and I won't go into the details, but basically it's looking at number of models that are trying to capture the observed trend over 1900 to 2019 or 1950 to 2019 or one particular model over 1920 to 2019. These are called opportunity analysis, where you take whatever you can get in terms of model simulations, in this case for a particular scenario RCP 4.5, which is middle of the way emission scenario. So they had 22 models and 45 members, so multiple realizations from some models and observations. So if you look at the trends as regression on smoothed global mean surface temperature, observational estimate is here, and you can see that the models are are all over the place. And this is from Cordex, which are regionally downscaled versions of the IPCC models, and you can see that for this period they are way off as well. And this is from CSM, which is the NCAR model from the US, and that's way off as well. So cautionary tale is that while we can say certain things with great confidence, like this northern hemispheric polar projections from 1979 to 2013, seasonal trends, there are changes in the wave patterns, frequency of heat waves distributed across the globe have increased. I think it's some 6 times, but again, these are large-scale patterns. So whatever we can say about large-scale patterns has to be then about what happens when you zoom in. So this is showing observations for 1961 to 2000, another global network here, a reanalysis product, blending of models and data, and these are the mean trends and standard deviation in the trends. And without going into details, I want to just emphasize again that even the observations themselves sometimes can be deficient or not good enough when you want to go down to the scales at which you want to look at something like heat wave. Heat wave is typically something in a town or within a city like Chicago. It could have a very different impact in a particular neighborhood based on the socioeconomics, availability of cooling centers, ACs, public transportation, and so on. So very, very local information is needed for forecasts, early warnings, actions, and so on. So this is another example from India showing gridded product of the trend in the highest maximum temperature over India, and you can see from 1979 to 2013 this product says something, whereas the ERA interim, which is a reanalysis product, looks quite different. And here this is for May to June 1979 to 2013, and this is the same thing from ERA. Again, big differences. So even the data may have some issues, but the models, especially the prediction models, have to be very important. They have to be reliable. So whenever you hear things like this, climate change made South Asian heat wave 30 times more likely, you have to ask the question, do we need attribution all the time? What are we going to do with this? Okay, so South Asian heat wave was made 30 times more likely. What do we do with this information? Does this say anything about what was the most important local factor? Was it deforestation, urbanization, irrigation, pollution, or was it all global patterns that determined this amplification of the heat wave? And what scale was increased? For example, in the summer of 2022, I think La Nina and the Arctic warming together created a pattern that extended further south into peninsular India. So how do natural variabilities contribute to these changes in duration, intensity, and frequency of heat waves, as well as the areas covered? So the main cautionary note, just again as an eulogy to Geert Jan, is that models are still not there yet in terms of their ability to do attribution. And the other thing we have to remember is that we always say models are much better at doing temperatures, which is true. Temperatures have larger decorrelation scales, easier to predict the dynamics and temperatures, whereas precipitations are much harder to do. So what does that mean then in terms of attribution of floods over Pakistan or particular place in India? So that gets even more tricky because data for precipitation is even worse than data for temperature, except in some particular places like India, for example. So all these things we have to keep in mind. So the other thing I worry about is that every time extreme event happens, the focus is on saying how global warming made it worse, but then there is a distraction from the fact that forecasts may not have been very accurate. So why don't we focus more on why forecasts were not done right? and how to do forecasts better rather than worrying about attribution so much, or always talking about how climate change will make these worse in the future decades. Everything is happening right now, so what can we do right now? So this requires more attention as well. Of course, people differ on this, and there are many people who like to talk about how much worse things will get in the future, but you have to decide for yourself, should we be creating early warning systems, better forecasts to deal with what's happening now, as we look at things like adaptation and mitigation to reduce these heat waves and extreme events in the future, remembering that they are often dependent not just on greenhouse gases but on very local factors like land use change, pollution, irrigation, all sorts of things. Okay, that's what I wanted to say today.